This is a weird problem. All it's giving me is simply a quadratic equation right here, right? Some kind of a x squared term plus some kind of a linear term, the mx, plus a number n, saying that equals 0. M and n have to be positive integers. Okay, so that's actually important. And m is greater than n. But think about all the things that this might be true for. 4 and 5, 5 and 6, 6 and 10, right? There's an infinite number of things you could pick for m and n. And then we somehow have to get from that to knowing which one of these or multiple of these statements are true. So I'm going to give you a way through this that might work depending on all the different versions of this problems you might be looking at. Sometimes m is less than n, sometimes m is equal to n, sometimes m is greater than n. Let's use the quadratic formula. You remember this guy. This is one of the best remembered formulas from Math 2 and Math 3 students. And what I'm going to do is plug as much as I can into this thing using the formula right here. Okay, so if you look at that formula, you can see that a is equal to 1, right? There is no a, so it's just 1 times x squared. So a is equal to 1, b is equal to m, so this becomes negative m plus or minus the square root of, well, what's b squared? That's going to be m squared minus 4 times a times c. Well, a is 1 and c is just n. So here's the formula after I plug everything into it. And now let's talk about the different sorts of things which could possibly be true. Is it possible that you have no real solutions? I'm going to talk about number 1 first. Is it possible to have no real solutions? Well, to have no real solutions, what that requires is imaginary things. Remember, you can have real or imaginary solutions. To get imaginary solutions, you would need something happening here that produces imaginary numbers. Well, what sorts of things produce imaginary numbers? It's when you try to square root a negative. So to get no real solutions, here's the requirement for number 1. Number 1 requires that m squared is less than 4n. Well, is that possible? If you think about m and n, they're greater than, they're positive integers, and m is greater than n. So what sort of positive integers have m greater than n? Well, the smallest positive integer would be 1. Okay? So let's say, I'm going to do a bunch of conditions here. Okay, let's first start with n equals 1 and m equals something greater than 1, let's say 2. That's about as small as these things could possibly be, right? Well, is 4 squared, let me be really clear, is m squared less than 4 times n? Simplify this. Do we get 4 less than 4? Nope, that's not true. What if n equals something else? What if n equals 2? And m has to be greater, so let's say m equals 3. Okay? So now we have 3 squared less than 4 times 2. Is that true? Is 9 less than 8? Nope. And if I make m bigger, that's not going to make this any more true. So these statements are all false. If you go through a bunch of these statements, you'll find none of these are true. So that means, I don't want to delete that. That means we can rule out option number 1. Okay. Option number 2, x has 2 distinct positive solutions. Well, imagine what the results of this might be as I'm looking at option number 2. See this right here, the square root? What sorts of things come out of a square root? It's positive numbers. They might not be pretty, they might be ugly decimals. But unless we're talking about imaginary things, you need positive results from a square root. You're never going to square root a number and get negative 3 as a result. Now, this plus or minus here has to be dealt with. But let's imagine for a moment what sorts of numbers we might get as a result of negative m plus or minus something. Well, negative m is negative because m is positive. Okay, so that right there tells you we're negative. And you're either adding something to it or subtracting. Now, if you're subtracting something from it, you're going to get a negative number. A negative minus something is still negative. Whereas a negative plus something could be positive, could be negative, we're not sure. So there's no chance I'm going to get two positive solutions, right? That can't happen. And what we're left with here is x has only a single real solution. Well, that may be true. Let's see what it would take to make that one true. A single positive real solution. That means we're getting something like this. X equals negative m plus or minus 0 over 2. And that would be negative m over 2. That's a single real solution. Well, how does that happen? That requires that m squared minus 4n equals 0. Is that possible? Well, can m squared be equal to 4n? Square root each side. Can m be equal to 2 times the square root of n? I'm not sure. Let's just guess something. How about n equals 1? Okay. What if n equals 1? Well, the result would be 2. Can m equal 2? Sure, that works. 2 is greater than 1. So you see this last possibility is a real possibility here. And I think, depending on the form of problem you're looking at, you should think about this in terms of the quadratic formula and really focus on this square root component of it, because that's going to tell you whether the results are imaginary, positive, unique, right? Whether you have multiple solutions or just one, and so on.